is a measure of time complexity, and it represents the amount of time it takes to run your full program or to go through each of the instructions based on the input. And this is really important because the more input you have running into a program, the longer it's going to take and the more it's going to stress out your computer. So you have to think about really large amounts of input and what that could potentially do with your program. We want a smaller big O, which does not mean we want a smaller amount of input. It's just we want it to not increase so much as your input increases. Usually we will think about the best, worst, and average cases for your program. So for things like the sorting methods, I'll show it in my code later, but we have an advanced or a bubble sort version 2, where originally the best, worst, and average case scenario of the normal bubble sort, it'll all be a big O of n squared, but in the best case scenario of the enhanced bubble sort, if your array or list is already sorted, it will actually only go through n times, which will, decrease the big O, which is nice. But we do want to pay special attention to the worst case scenario because that's when it has the potential to take forever to compile and output and stuff like that. Okay, when we are computing the big O, we will drop constants and favor larger big O's. So the example I have is for, say that each of these brackets is some function, and our program calls both of these functions. So it will call a function with a time complexity of 2 to the n, and then it will call a function with a time complexity of n. Because 2 to the n is greater, we will say that this whole program will have a time complexity of 2 to the n. So that's an example of favoring the larger time complexity when you're computing it. Oh, that's not what I wanted. And then dropping the constants. Say we have the two functions that are they're both have a time complexity of n. If we call them both, you would add them together, so it would be a 2n time complexity, but it would be the same thing as just having a time complexity of n. And then some of them we refer to with fancy names, and they're just kind of references to math terms and things that we know. So a big O of 1 is considered constant, so that would be a program that's not impacted by an input. It will, run a certain amount of instructions no matter what. There's nothing to change. And then linear is our next. The other one that I made most sense to me, where a linear function is just a straight line. It'll be as your input increases, your time complexity, or the amount of instructions and stuff will increase, and it'll just be a 1-to-1 increase as your data grows. And then here's a few more examples of kind of just calling some things the same time complexity. So here, these are all big O of n, and usually you could tell a big O of n when it just changes when you're using the input, the n in one place, and you have kind of like addition or subtraction. So here we're adding, subtracting, and then we're basing in here and here. The log in comes from, using the input numbers, but then also multiplying or dividing by this. And so here you'll see log 2 of n, it'll be I times n, or I times 2, or I divided by 2. They're both log 2. And there's another example of this for sorry, lost my train of thought. So they're log 2, and then you have, if you increase it times, so I times 3 instead of I times 2, it'll be a log 3, and same thing, if it was I divided by 3, it would be log 3n. And that happens as well with the 2 to the n function, or 3 to the n function, that I show in my code in a second. This is our graph. Our best ones are down here. This was that like linear line that I was talking about with ON. And then we were told that these first 3 are the best. This is the order of complexity. And then n log n was not really bad, but it's not really considered good. So okay. So now this is the example I have for 2 to the n, which, because it has 2 recursive calls, it'll make it 2 to the n, and this is what I mean again. So if I had another recursive call, it would be 3 to the n, or if I had a 4th recursive call, it would be 4 to the n, and so on and so forth. So that looks like this. So if I run it, and then, you see, and then it'll do a little thing there, and it'll be it's my 2 to the n. Okay, and then I have my log of n, which I realize it'll tell you it's like telling you the binary bits representations, which I thought was kind of cool. Let's go with like 8. So it'll be like the bits would be, this position represents 1, and this one represents 2, and this one represents, stuff like that. Anyway, I thought that was kind of neat. So this is log n because we have our multiplication here to change our I, and then here's the use of n. And then n log n is, okay, so this is n log n because just like before, this is the same log n function, but then we multiply it because it's nested inside another for loop. We would multiply this time complexity, which is n, times this complexity, which is log n, which would be a total of n log n for that. And it, does a little thing too. Woo. And then, yeah, that one, again, a lot more things happening. And then for my linked list, I don't even know how do I explain this. So I created a linked list, and then something with a time complexity, like a constant time complexity O of 1 would be like this empty function, because it's always just going to return if head is a null pointer or not. It doesn't matter how many nodes are in the list or the lack of nodes in a list. It will always just do this one line, and that'll be its complexity. And then I created an add. I created an add function. So this has a time complexity of O to the n because it iterates through to the very end of the node to add it onto the end of the list. Same thing with print. It has a time complexity of O to the n because it just iterates through once. And then I did a bubble sort, which has a time complexity of n squared because it doesn't look like two nested for loops like all the examples, but this while loop and this for loop are each have a big O of n, so when you multiply them it'll be n squared. And yeah, and then I have a swap function just because it was easier, but I could show that too. Oop. Oh, and here I can, oh, did I not? I didn't comment something out, sorry, one sec. Here we go. And then I used this size of the list to help create my bubble sort for loop, and that would be the quote-unquote n that is changing as that's the n input that's changing based off of how many things you add to the list or things like that. So, you know, this would have like an n of, or it would have input 5, and then if I added more people, that would have a larger input. So yeah.